This lecture 26 is based on lecture 25, and in this previous lecture we saw one trigonometry function where we converted our sine square x into cos 2x, and here I am giving direct value of cos 2x, and we'll see one small like a good idea that will help you by using this trick. So in this question, you know, whenever these kind of questions are coming, what you have to do, you have to first find out if you want to find out your complete solution, then you have to find out your complementary function and particular integral pi. This should be pi. So anyway, this to find out your complementary function and pi, you have to find out your auxiliary equation fd, that is well known to us. So d square plus d plus this should be actually 1. Why it should be 1? Because this is my mistake. You can see if we take y common from the equation, y common from here, y common from here, y common from here, so plus 1 will be, so it should be d square plus d plus 1. Okay, so d square plus d plus 1, if you find out the roots of the equation, it will come minus 1 by 2 plus minus I root 3 by 2. Okay, so alpha value is minus 1 by 2 and beta value is root 3 by 2, right? So these values we got for alpha and beta. According to that, we'll write the solution e power alpha x bracket a cos beta x plus b sin beta x, right? So this became our complementary function. But now to calculate our particular integral, you should remember what? You should remember that in case of sin ax plus b or cos ax plus b, you are going to convert your d square as minus a square. How will you search a value? A value is nothing but coefficient of x is your a value. Okay, anyway, and how do we calculate pi for any function? We simply write that function and we divide by fd. Okay, you can say the operator 1 by fd, right? Now this fd value is nothing but equation. Which equation? Auxiliary equation d square plus d plus 1. Okay, done. Till here it's all right. Now that coefficient of x is a, that is 2 here, so a square is 4 here, so a square, if you take negative sign, means minus a square is minus 4 here. So this d square you will replace with minus a square. This is what is the special thing about sine 2x and cos 2x, right? Okay, after that what will you do? You see here cos 2x is here as it is. Here I replaced minus 4, done. This minus 4 and this 1 became minus 3, so this became d minus 3. You should note this. In last lecture 25 we were remaining with only 1 by d, but this time we are remaining with d minus 3. How it is difficult now? See, last time when it was only remaining 1 by d in lecture number 25, then this 1 by d we wrote simply like integration dx, correct? But this time we cannot write because minus 3 is present. Okay, so in that case what are we going to do? Simple trick. We are going to multiply d plus 3 in numerator also and d plus 3 in denominator also. So denominator will become a plus b, a minus b will become a square minus b square. So d square minus 9 we got here. Okay, now further you replace d square. This d square is here, right? Further you replace this d square with this thing, correct? Minus 4, because that is minus a square. Okay, so now you can see minus 4 and 9 became minus 13, so we got minus 13 there. So this total became minus 1 by 13. All right, now this d plus 3 is there. Now remember what is the meaning of d? D means d by dx. Okay, d means d by dx, keep in mind. So this entire cos 2x you multiply in d also here and then multiply in 3 also here. So d plus 3 multiply cos 2x, so here you will be having d cos 2x plus 3 cos 2x. So 3 cos 2x is nothing, that is simple thing. But d cos 2x, here d means d by dx. It is an operator. It is telling you that differentiate cos 2x. So when you differentiate cos 2x, minus 2 sin 2x will come, right? And this 3 cos 2x is as it is here. Okay, so this became my particular integral. You see, we got our particular integral. Why this option why this question I have chosen? Because in lecture 25 you simply got 1 by d and question became easy, but this time we are remaining with d minus 3. So in that case, how did we tackle? This was the main takeaway in this lecture. Now to find out complete solution, you know, you have to add CF and you have to add PI, and you learned both, and you can find and add. That's all. Now we have to find out PI for those cases where x square, x cube, it means polynomial type of things are coming in the right side. For example, x plus 1 will come in the right side. For example, x square minus 2 will come in the right side. For example, x square plus x plus 1 will come in the right side. So in these kind of polynomial cases, how to handle the situation? Okay. So I have written here, now particular integral we are going to find out for cases where polynomial like x square, x cube, blah blah things will appear in the right side. So how to handle that? So see here. In general, I can give that name as x power m case we are going to deal. Like sin ax plus b case we did, cos ax plus b, e power ax. So now this is kind of different kind of function, x power m we are going to deal. So first thing, how do we calculate pi for any function? We just divide that by auxiliary function equation, that is 1 by fd. Okay, but in this case you can see in every cases we are doing different things with this operator, correct? When it is about the sine cos, then we are replacing d square with minus a square. Okay, but this time we will not do that. When it is e power ax, then we are simply substituting d with a. But this time we will not do that because it is polynomial. In case of polynomial, what are we going to do? Whatever fd is there na, that fd you take up and make it like fd power minus 1. From denominator you take that as numerator. Okay, once it went there, then here you will apply binomial expansion. Here you will apply binomial expansion. What is binomial expansion, guys? You remember bracket 1 minus x power minus 1 we used to expand, correct? We used to expand this, right? Or 1 plus x power minus 1 we used to expand, or minus 2, or minus or plus 2, or here this thing we used to expand. So if you want, I mean all the powers will be negative. Here sign will change, plus minus, but powers will be negative always. So there we used to apply binomial. Don't worry, you have forgot, I will give you those equations in this lecture itself. Just to understand, when you are expanding, suppose you are expanding any 1 plus x or 1 minus x, then in ascending order we used to expand, not in descending order. It's like 1 plus x square plus x cube plus x power 4. Power is increasing, ascending. Okay, so how much you will expand? If you have to expand this, how much you will expand? So you will expand until you are not reaching to the x power. X power means, suppose x power is 4, then you have to expand till d power 4. Okay, you will see in the solution, you will see in the example. So just one thing I have added here for your memory, and remaining again I have given the lecture. 1 plus x power minus 1, how do you expand? 1 minus x plus x square minus x cube plus x power 4, then minus x power 5. So you can see, right? This is the expansion. So how much you will expand? You will expand only till x minus 1, or you will expand only till x square, or you will expand till x power cube. How will you expand? So that you will decide what is the maximum power here in the right side. So in this question, maximum power is 2. Okay, so when you will expand in terms of d, maximum d power 2 you will expand. Okay, see the example. In this example, you can see left side is the simple term to find out your complementary function. I am not going to find out complementary function in this lecture. Directly I will attack particular integral pi. So in case of x square plus 2x plus 4, this is first you judge this is a polynomial. If this is a polynomial, then in case of polynomial, what is our job? Our job is this, whatever 1 by fd is there, we will take this up in numerator. Okay, so that is nothing but 1 by d square plus d. How it is 1 by d square plus d? Take y common, whatever is remaining, that is d square plus d. Okay, now in that d square plus d you take d common, so it became d plus 1, d in the bracket d plus 1. Now this 1 by d you leave as it is, 1 by d you leave as it is, and this d plus 1 is there, na, that you take up, because expansion is only for 1 plus x, 1 minus x, 1 plus x, 1 minus x. Okay, so 1 plus d you take up, it became 1 plus d power minus 1. Now here what I am doing, see, this is not 11, it's like I have just copied this here, I have just copied this everything, x square plus 2x plus 4, x square plus 2x plus 4, x square plus 2x plus 4. So here also in this bracket you have x square plus 2x plus 4. So this x square is the maximum power in that right side thing in the polynomial. So when you expand this 1 plus d power minus 1, then you will expand till where 1 minus d plus d square, and after that plus d cube and all will come. That is no need in this question, because I know my maximum power is restricted till x square. If in the question itself it is like x cube, then we have to do, but right now it's all right. So now this x cube wala term will leave, right? So this d cube, this entire term, no need. We are only remaining with 1 minus d plus d square, and in the bracket x square plus 2x plus 4 will be there. Okay, then this bracket you multiply with this 1 and this minus d and then this d square. So then it will look like, you can see with 1 I multiplied here, then with minus d I multiplied here, and then plus d square I multiplied here. Done. Okay, now what is d? D means differentiation, correct? D by dx. So here everything will be as it is because multiplication is with 1, but here d is present. D is means for one time differentiation. So x square will become 2x and this 2x will become 2. Why minus sign? Because minus is here, so this and this minus will appear, right? Okay, and this 4 will become 0 when you will differentiate one time. Now interesting thing is this bracket. In this bracket whatever is present here, x square plus 2x plus 4, but here outside you have d square. D square means 2 times differentiation. So you see, when you will go for 2 times differentiation, then this x square will become 2x, and then that 2x will become 2. So answer will come 2. Think about this 2x. First differentiation, answer will come 2x. Second differentiation, answer will come 0. So leave this 4 in first itself 0. So we got this thing. So now in this we have few things. 2x and 2x will get cancelled. This 2 will get cancelled. So x square plus 4 will be remaining. And you know now what to do with this d. So 1 by d, whenever you see, that is nothing but giving you indication, integrate this here. So after integration, whatever you got, this became your pi. Okay, now we'll also see some polynomial problems, but before that you keep in mind important polynomial expansions. 1 plus x power minus 1 is 1 minus x plus x square minus x cube plus x power 4 minus x power 5, blah blah blah. Okay, only these 4 I have given. Why? Because in GATE exam, only for this topic only these 4 are sufficient. So if you have minus sign, then everything will be positive. If you have power minus 2 with inside plus sign, then 1 2 3 4, in every term 1 2 3 4 will come. It means whatever answer is here, in this answer you just multiply 1 2 3 4 like that, and you'll be getting this answer. And if you have 1 minus x minus 2, then all the sign in this will become positive and you'll be getting this result. Okay, just note down all these 4 important binomial expansions and then go for lecture number 27. There we will be discussing some more examples for polynomial to calculate pi, and only that much will be enough for GATE exam for ordinary differential equation for GATE aerospace. Then we'll move to partial differential equation as a separate unit. Okay, and it's not like the last lecture will be the last lecture. We have to practice also. So but first let's finish the syllabus and then we'll see the numericals. Okay, so we can stop this.